4. So, has anybody ever suspended their Linux laptop in here? Good. And did it work?
Yeah.
I presume.
Once.
No. Okay, so who is expecting the annual I'll make your suspend work talk today? You're wrong. This time it's not. I'll try to be a little bit of the oracle and tell you something about the future of suspend, or what I think will be the future of suspend. So since it's working for everybody, I don't need the we'll make it work talk. We'll do the what's going on next, what's going next, what's going on, and what will be the new features, what will be the new development. So this is today the future of Linux suspend, or how I see it. Yeah. First, I'll describe what's the state of the art now. That's what most of you should already have seen sometime. The second part is what's next. That's the more interesting part. So today, if you want to get suspend to run working, basically from the kernel side it's working well. What does often not work that well is getting the video card back to life. I've had a long a talk especially about this last year, and it was very interesting for many people, but basically today we need to somehow identify the machines that work, and we need to whitelist them based on some matching, if it's a DMI match. And there are two ways to whitelist them today. One is the whitelist in S2RAM. Users of OpenSUSE who have ever file a bug against suspend to RAM, this bug will be assigned to me, and I will tell them to go to the suspend to RAM site on OpenSUSE or Wiki and get their machine whitelisted. There are lots of options. The suspend to RAM tool is part of the user space open source forge. It has a pretty good whitelist, pretty extensive, but also the benefit is a standalone program. You don't need any other programs installed basically. It just S2RAM, it has everything built in, including the whitelist, and that's also a drawback of this program. It's a little bit unflexible. To change the whitelist, basically I edit a C file and you have to recompile the program. We have some conceptual problems because we only do DMI matching. That's the SM BIOS strings that are in the BIOS, where we match, okay, it's a Dell D600 machine. Unfortunately, some machines are shipped, for example, with different video cards. You can get the same Dell machine with an Intel video card, with an ATI video card, and with an NVIDIA video card, some of them, and there's often no way to distinguish them by DMI matching. Maybe Dell knows there's some different serial numbers or something like that, but you don't want to match on the serial number. So we can't do that. And yeah, it needs to be recompiled, as I already said. The second whitelist is kept in HAL. In HAL, it's also pretty extensive because basically we're merging the whitelist first and back as long as it's possible with the S2RAM infrastructure. HAL is much more flexible to match. You can match, for example, on the PCI ID of the video card. Additionally, usually they also do DMI matches, but you can additionally match on the PCI ID of the video card. So you can distinguish those D820 from Dell with the video card and the D820 with the Intel card. You can apply different options. Basically, that's the problem, that you sometimes need different options depending on the video card. Another good thing about HAL is that you can easily extend it by adding an FDI file. That's what Timo showed you in his talk before, that you just change the FDI file and HAL knows something new about the hardware. The downside is you need HAL running to use it actually, which means you cannot just go into init bin bash and try it out from there, because there you have no HAL running and you have no database. That's the biggest drawback of using HAL, and actually one that's considered major by one of the suspend developers, but well, he doesn't maintain the whitelist. Then we're by okay. Suspend to disk. No, suspend to RAM is over, it's the state of the art. Suspend to disk. There are different methods. There's the old proven kernel method where you just do echo disk into sys power states, the machine suspends into the swap device. It works. I have not a single bug report for 10.3 for those methods, maybe because it's no longer default. It has no fancy option, it's relatively slow, but basically whenever somebody has a problem with suspend to RAM, suspend to disk, everybody will tell him, try the kernel method. If this works, then it's not a driver problem, for example. It's for quite some time in kernel. 2.6, I'd say it's usable since about 2.6.5. It was in the first months, it was very adventurous. Then there's the user space suspend. That's what we in OpenSUSE are using as a default now, where some parts of the suspend process just got shifted from the kernel space to the user space. Basically the stuff where the kernel developers didn't want to tackle with. Compression, encryption, somewhat fancier user interfaces, progress bars and so on. Stuff that when you try to push those to Linux Torvalds, it says, oh, go away, I don't want your fancy learning stuff. I run X, that's enough code for me. It started out as a hack, but it's since in mainline kernel since 2.6.17 and it's working quite well. It does for me. We're coming to that later. Then there's Tux on Ice. That's formally known as Suspend 2, which was developed by, as a kernel patch by Nigel Cunningham, who's a very nice guy, by the way. And he's maintaining this since 2.4 days. And it's relatively easy to set up once the kernel is patched and built, but that's a little bit of a problem, of course. It has lots of fancy options. It can do compression, encryption, splash screens, text mode user interface, almost everything. And it does this in kernel space. And that's where most of the kernel developers say, no way is this stuff ever going to be merged. And it's quite well supported. It has a quite huge following and many users are very happy with it. This does not mean that the kernel developers are happy with it, but users like it and it deserves to be mentioned. And as I said, Nigel is a very nice guy. So that's what we have now. Those are the methods. In user space, there's nothing new to tell since last year. We're using PM utils, which is evolving. Our safe daemon is no longer used for suspend since 10.2, I believe. There was still the possibility, but then we shifted to HAL and PM utils, as everybody has probably heard in last year's talk. So part 2, that's the interesting part. What's next? Do you already? So in the future, right now it's going on. For suspend, there's a mechanism, it's called the freezer. That's everybody who has tried to suspend and has not used the splash screen has probably seen stopping processes. And 1 in every 100 suspends, it probably said failed and just returned to the graphical display. This sometimes happens. The freezer stops all the processes so that the machine is really quiet and later the kernel can do its atomic image copying stuff and so on. And the freezer, it has some problems. Usually processes that are in state D, which is basically waiting for I/O, they cannot be stopped. And people complain about the freezer on the Linux kernel mailing list, and then some high-profile kernel developers say, okay, this freezer stuff is broken anyway, so right now it looks like it will get removed, sooner or later. Probably later, but it will probably be removed. And there's just, there's a very prominent kernel developer last week again was ranting against Suspense. It's this Finnish guy. And he's also one problem and says, okay, this freezer, maybe we should do away with it. This will happen first for suspend to RAM, just because there it's much easier. And later, but probably it will also happen for suspend to disk. It will not happen soon, but it will happen. The removal needs to be carefully considered because there are many parts of the kernel who just don't expect that stuff vanishes under their feet, and so we will see many interesting kernel loops on the way to have the freezer gone. Because right now, the system is put basically in a consistent state, all processes are stopped, nobody will do DMA and stuff, and then we copy the image to the disk, for example. Or we tell the BIOS to now shut the core machine down, we by ourselves, we save the CPU state, and then we tell the BIOS put this machine into suspend to RAM. So it's always in a consistent state, but the freezer makes, for example, suspend to RAM slower than it needs to be because it has to stop all processes, it has to wait until they're stopped. And sometimes it fails. That's the the greatest problem is that it sometimes fails. So that's, yeah, what annoys people. And instead, the trend goes, instead of we fix it up, people have to, it's not really fixable. There's discussion about that, but the discussion is probably basically over. It will be removed. I don't think removing the freezer will solve all those problems automatically. We will just see shiny, new, better problems. As always. Then there's work going on in the driver infrastructure and the power management core. Rafael Wysocki is also a very nice guy from Poland. He's doing quite a lot of work in the background of power management stuff, and he wanted to do this, the overhauling of the driver infrastructure for kernel 2.6.24. Kernel 2.6.24 is out and running on this machine, and the infrastructure is not completely overhauled, just because he did not want to break everybody's machine. So he said, okay, first he has a daytime job he has to do, and then he needs just more time. That's part of the discussion he had with this Finnish guy last week, where Linus basically said, why are you using the same code path for suspend to RAM and for suspend to disk? Which is a valid question, and this was asked years ago. So basically, in former times it was just easy. Somebody had developed the code path for suspend to disk, and they just used the same resuspend the drivers, and so everything was done the same for suspend to disk and suspend to RAM. Now you can argue that those are two totally different things, or that those are similar. That's an argument that has been fought on Linux kernel mailing list for 2 years, and basically today everybody agrees, okay, we'll separate it, but somebody needs to do it. That's Rafael's job, he's doing it now. It's going on slower than he planned it, but it will take place. There's lots of background work that you don't see done in all the drivers, in the power management core. All those drivers now, until today, they only have a suspend method. So if you do suspend to RAM or suspend to disk, they get the suspend method and they shut themselves down mostly. Now they get two methods, a method for suspend to RAM and a method for suspend to disk. And most of them will probably behave the same, but some will just say, okay, I don't need to do anything for suspend to RAM because the system will take care anyway that the state is restored after suspend to RAM. But for suspend to disk, we are sure we lose power and nobody will help us with that, so we need to reinitialize from scratch. It depends on the driver. This needs to be done and this will take some time. Then there's the question, will there be a merge for suspend to RAM 2 for suspend 2? And Nigel did some efforts around a year ago or 2 years ago. He wanted to merge suspend 2 to the mainstream kernel because maintaining a patch outstream of the 2.6 mainstream kernel is a pain in the ass because it changes so fast. You have to adapt to what in former times was from the change from 2.2 to 2.4 is today, I'd say, from 2.15 to 2.20. 2.6.15 to 2.6.20. So the kernel changes very fast, and the kernel developers say, okay, that's an internal interface, nobody should use it anyway, or they should push their stuff upstream. So he tried to push his stuff upstream, but for the reasons said before, there's lots of user interface stuff in there, and it will probably never go upstream. That's what many of the involved parties have told me. So then the next problem is the suspend 2 is heavily dependent on the freezer. He has also done improvements to the freezer so that for him it works better, but those were considered highly complicated. There was some stuff in there where the kernel developers said, well, maybe this works for you, but nobody can explain why it works better than the old one. So as long as we don't know why this fixes the problems, why make it more complicated than it was? Maybe it's just voodoo cult programming. So he has some problems. His problem now is that the freezer is going away sooner or later, and then the suspend 2 or tux on ice concept, he will have to take care of that. That's probably not an easy job. What Nigel is doing, he's contributing lots of, through his huge community he has, his large community, he's contributing lots of fixes that where he gets a bug report and he finds out, okay, that's not a suspend 2 or tux on ice, sorry, a tux on ice problem, the project got renamed. It's not a tux problem, so he fixes the driver and sends the driver fix upstream. So Nigel is continuously contributing good bug fixes and he's really doing a great work here. I think he deserves more merit for what he does, and he's really fighting a Sisyphus battle, because it will not get upstream. Probably. I'm worried. Then there's some funny guys. They think, oh, this suspended disk is totally broken, it never worked for me, and we could do this using kdump. Kdump is a tool for, if I understand it correctly, it's a tool for getting crash dumps. So you crash the kernel, it puts all it, like a core dump, but from the kernel onto some partition, wherever. And basically, if you do not necessarily crash the kernel, but just say, okay, dump core, and later load this core file and start it again, well, you did a suspended disk and resume. And there was actually somebody who did a presentation at LinuxConf Australia and said that will be the way for suspended disk. So I said, okay, this guy is sometimes proposing interesting stuff, and I asked around, and some people think he had smoked something strange before he held this talk. I'm not sure. I haven't heard it. The problem is, it's a 2-hour hack to get this working. If you sit down for 2 hours, you get this working, but this again will not, with some magic dust, blow away all the driver problems you had before. They will still be there. You still need to reinitialize your devices. You still need to make sure that you load the correct image back and so on. It's an interesting proof of concept, but nobody knows what the real benefit is. And so it will happen. It will come to the mainline kernel sooner or later, but it will not replace the existing methods with the user space suspend and the kernel space suspend. Or as Raphael has told me, this will be the new way to suspend once he sees a working implementation that's comparable with features, speed, reliability, and ease to set up, and then he made some blank lines, which is probably never. We will see. Everybody is working on is waiting for a working solution. That's actually, in the end, I don't care. I really don't care how the suspended disk is done, as long as it's working, it's fast, and it's reliable. So we'll see. That's one of the possible things to do. Then a pretty interesting project where Pavel Matic is working on is Sleepy Linux. It's called Sleepy Linux, where he basically says, okay, sorry, and he says, we need to push suspend to RAM much harder. So if the system is idle for, say, 10 seconds, why not suspend it in this time? And this is, he has a working prototype. His tagline is, the hardware is capable of doing better, but we don't use it. And one problem is that, for example, now when suspend to RAM, the BIOS switches off the displays. But with some help from the vendors, from the BIOS vendors, from the hardware vendors, we could probably suspend the machine without switching off the display. And then you could still read your mail. And once you push a button, the machine wakes up and it displays the next mail, and it can go to sleep again. And this is stuff where Linux, I think, in the PC world leads the pack, because on Windows, Vista just got worse with the power consumption, and we are trying to get even more small stuff out. And actually, who has seen the Nokia Internet tablets? They are doing the same. They don't have a dedicated suspense state. They just switch off more and more hardware that's unused at the moment. And if it's unused for 3 minutes, they also switch off the display and probably stop the CPU clock or something like that. And then the machine is suspend. It's not. They don't. With some help from the hardware vendors, if we show that this is doable, maybe Intel might be interested in support this better from the BIOS, and it will never work as good as on those Internet tablets with those embedded processors that are especially designed for it. But we can probably do much better even on PC hardware. So that's an interesting thing. I will not be able to show this on next FOSDEM in full working condition, I'm sure. But it's interesting to work on. Yes?
Isn't the OLPC doing something similar?
Probably yes. Yeah.
So there we look at an x86-like system.
Yes, exactly. So it's mostly a matter of firmware. It's not a matter of the hardware. The hardware can often do it. But the BIOS is not prepared. We don't have we now have a ACPI mode S3, which is a full-fledged suspend to run, and there the display is off. It's defined this. And so maybe we need a state S2.9 where the display stays on, and the graphics card still renders the image. That's also so, and where the machine no longer consumes 10 watts, but maybe only 2, and that's okay as long as I can read my mail with something like that. Yes.
What if they integrate this functionality into the drivers? And the driver shuts the hardware down when it's not used.
That's also happening right now, for example, with USB auto suspend.
I built this in hardware 2 years ago.
Yes, PC hardware is quite stupid often. And nobody cared about stuff like power management until maybe 2 years ago. Yes, those laptops, but well, they did not bring the money. Right now, today, as everybody is wanting to get Energy Star compliant, as data center power consumption is really an issue, that people are willing to pay more money for hardware that is able to run with lower electricity costs. This is all stuff that's going into it. It's not only the Suspense stuff, but it's also the runtime power management stuff that will be in the drivers and maybe even in the hardware. So yeah, we will see improvements in that, I'm quite sure. So the future in the kernel side, and now the future on the user space side. What will happen to this suspend whitelist? Obviously, some of you will have thought, well, why do they have 2 times the same whitelist? The suspend to RAM whitelist is maintained by me, so I'm guilty of promoting one of them, but actually now I'm trying to get rid of it. Because first it's a lot of work maintaining it, and then we've just found out that it doesn't scale well. We can only match the MI strings in suspend to RAM, and of course I can now start building a infrastructure where I can also match PCI IDs. But then the problem arises, probably you have different options to suspend if you have installed the binary only NVIDIA driver, or if you're using the open source driver. So which option do you put into the whitelist? With HAL, I'm not sure if you can do this now, but it will be pretty trivial to match on some installed software version, or just let the software install or set some key somewhere where it's okay, we have the binary only driver, or we have the free driver, which need different options. So I'm basically saying, okay, we will drop the suspend to RAM whitelist sooner or later, we'll put it into HAL. For the user, this will make no difference, because the user hopefully just clicks onto his power manager icon or presses Fn F4 on the ThinkPad and the machine just suspends. So he doesn't need to know where the whitelist comes from, and we will concentrate the efforts to put one good whitelist together, which is even bigger and works on even more machines than maintaining 2 in parallel. So somebody have told me this sentence is a little bit misleading. We will not only move the S2 RAM whitelist to HAL, but the efforts will move from maintaining the S2 RAM whitelist to maintaining the HAL whitelist. And then for some it means, okay, you need to have HAL installed, otherwise you won't be able to suspend out of the box. But basically that's true already. With the SUSE suspend, with the SUSE 10.3, suspend is done via HAL and PM utils. Yes, you can call PM utils manually as root on the console, you can call PM suspend, but I'm quite sure that's not what everybody uses every day. And the one who wants to use it from the command line can still do a wrapper script which calls S2RAM with the options he needs for his machine. So I think it's not that bad as Pavel usually puts it. Pavel is the one who says, I want to be able to suspend from init bin bash without having HAL running. And I say, yeah, okay, then take over the whitelist maintenance. He doesn't want that. So this will probably happen. PM utils has some pretty interesting stuff going on, because it got forked effectively. A new maintainer has taken over, basically without consulting the old one, if I understand this correctly. And okay, the old one wasn't very responsive, so often there was silence for a month on the mailing list, and then he replied to mails, and well, during 1 month of silence, the project got moved to a JIT tree, and there have been lots of commits, but I have still to see a real bug fix or something like that. So development is ongoing for the user, not much will change. The distributions will package it up. They can use the old version, the new version. They both work well. It's basically, I think it's feature complete, most of it. So that's what happens in user space, a little bit more. And now it comes to you, the users. What can you all do to make this future brighter? Who has reported a bug against suspend in here? Against distribution, against the kernel or something like that? Who, now again, who had a resume failure? So, where are your bug reports? This is really an important issue. It's, as I told you before, I always expect suspend to disk working just fine for everybody, because it does for me, and I have very little bug reports against it. So, apparently it just works. So, the problem is, everybody probably thinks, well, this stuff doesn't work anyway, so why should I file a bug report? That's wrong. You need to file bug reports. You need to file bug reports at those kernel developers who don't fix their broken drivers. You need to file bug reports at the distributions who don't package it correctly. File them. If it's a distribution bug, if you're using OpenSUSE, go to bugzilla.com. If you're using some other distribution, they sure have a bug tracker. That's file bugs. If they don't want it, okay, then if they say go away, we don't want suspend to work. But I'm quite sure they won't say that. Yes?
I didn't have a resume failure. I hit suspend and the screen went blank and then it woke up again. It couldn't go to sleep.
Yes, that's also a bug.
And there was no log messages, no error
yeah,
messages.
Then file a bug.
doesn't work.
If you
oh my
only
god, what happened?
Yeah, then file a bug, and if you're using SUSE, the bug will probably get assigned to me. And then I will say, okay, the log file is there. And if I get 10 people, it doesn't work, I didn't find the log, then I will think about, well, maybe documentation should be better. That's, even if you find the bug in the documentation, that's a bug. Even if you say, I cannot find the documentation. Yeah, that's also a bug. That's probably the most serious bug if there's no documentation. And I know it. I'm guilty of not writing enough documentation, of course, and there's always stuff that needs to be done first, but we need to fix that. So, yeah, file bugs. Even the kernel developers, they are ugly, loud, they are probably they're eating their children or something like that. They're all mean, ugly people, but they don't bite. And basically just bite back if they do. So if they write broken software, they need to fix it. Even if it's the kernel, and even if it's this all hyper prominent guy, if you have a detailed bug report, he will probably be a nice guy and say, okay, come back or try to let us kernel. Oh, we fixed this. Oh, that's an embarrassing bug. It often happens. Do not, all these resume failures, all the suspend failures, do not accept them. They are not given by God. This is a bug you need to report. It's important that it's your job. It works for me. But can I say it works for me? So I can, as long as I don't know that there are bugs out there, I can fix them. Even if I know there are bugs, I sometimes also can fix them. I have to confess it. There are bugs that will just get fixed won't fix in Bugzilla, which is often in my case I can't fix, and I write there, sorry, I believe you, it doesn't work for you, but I don't have the hardware, and without the hardware at hand, and sometimes even with the hardware at hand, I'm just too stupid to fix it. So, but even then it's important to know that there are problems out there, because for OpenSUSE 10.2 I was quite sure suspend to disk it work for everybody, because I haven't got a single bug report, one or two, but these are clear user errors, and I didn't get many bug reports for suspend to disk in 10.2, and later I found out it didn't work for anybody, but nobody told me, so that's a problem. Because I need to know where we need to work on. Everybody, that's for every project almost. Yeah, and again, I really want to promote this. Bug report on SUSE factory, bugzilla.com, product 11.0, component mobile devices. It will get to me more or less directly, and we will try to fix it. That's the real important thing. Okay, these are the usual interesting links. So, yeah, any more questions? Something you want to tell me? Yeah.
Are there any plans to support switching from suspend to RAM, from a suspended notebook which is running out of battery to suspend to disk? And actually, so that Windows Plus support this?
Yes, actually what's there, what's already there in the framework, but I have not gotten to implementing it in the user interface and in the PM utils is we can do a suspend to both. So we first write the image to disk, but then just do a suspend to RAM.
It's not an option. Suspend to disk is that is low if you have a lot of memory. And I want to switch it off immediately, and I don't want to wait 2 minutes. But if it's running out of battery 3 days in my pocket, in my bag, then it should suspend the disk.
The problem is, yeah, the suspend to both is relatively easy because you do a suspend to disk first, but then don't switch it off. Instead, do a suspend to RAM. To do what you want, that's what the old IBM Ready Safe did on 10 years ago on ThinkPads, is they wake up after 3 hours of suspend to RAM and then do a suspend to disk.
I'm sure this is working on G16.
Most modern hardware will automatically wake up if it gets low on battery, so then you just detect that you're critically low on battery and you suspend to disk.
Yes.
It already works if your user space is configured correctly.
Yes.
You do not want to wait until the battery is actually dead.
Yeah, so it's, what I will offer, I hope I will get it ready for 11.0, is that we can offer the suspend to both as a configuration feature. The problem is with the wake up on alarm timer or wake up on empty battery is that you don't know on which machine it actually works. So we need to have some kind of whitelist or something like that, which is, we need somebody who maintains this, and that's basically a problem. It's a resource problem. So you will probably get suspend to both, easily configurable, and basically you can still just say suspend and pack the machine away as long as it works reliably, and you assure that it works reliably by reporting every bug you find. Okay, more questions? Okay.
So when you're talking about sleepy Linux, one of the problems there is that you'll have to accept a certain amount of loss of functionality in some situations. For instance, you said you won't need to change hardware, whereas in the old PC case, in order to have wireless continue to work in a useful way, they need to have a wireless chipset that basically runs its own 8-11 stack.
Yeah.
And most hardware is not capable of doing that, so you're going to not be able to do this while also using a wireless network.
That's what I actually said with, we need support from the hardware vendors, right? So
It's
prototyping.
A large amount of extra expense in the wireless hardware. That's going to add like $1 per.
Yeah, but maybe once the
really sold on.
yes, but Pavel is prototyping this, and once he says this would be working if you would be selling appropriate hardware. Maybe companies like Intel or something say, okay, we can put this into the firmware probably, or we can do a little bit the hardware just. It does not need to be the chipset they use.
The wireless chips nowadays are not anywhere near it. Most wireless chips don't have anywhere near enough hardware capability to do this. You need to go back to full max.
Probably you say, okay, it doesn't work when wireless is turned on. Right. I can still do my presentation here with the machine most of the time sleeping. So it won't work in all cases, and it's a prototype yet. It's ongoing work, and we never know. We don't know, even Hans said he doesn't know if it leads to anything. But it's an interesting project, and that's why I wanted to show you, to mention it. Yeah. Okay, I think time's used up, so thanks for coming.